Awesome, thank you so much for the warm welcome. As you already know, I'm Paula Januszkiewicz, and let me do a couple of words of introduction about my background, and let's immediately get into the super exciting subject, which is, of course, the hacker's perspective on the new risks. So we're going to talk about what kind of priorities we took in 2025, and eventually how we should revise them for the 2026. And long story short, my background is pretty straightforward. Yeah? So in general, you know that I do cybersecurity already, and I do it for the past 20 years, which sounds like a long time, but cybersecurity today has a completely different meaning in comparison to what it was actually 20 years ago. 20 years ago, it wasn't really called cybersecurity. It was more called security and was part of IT. Right now, of course, it's a big separate thing. So my background has been always pen testing. My family would probably call it researching, or that's what they're supposed to know, or hacking versus researching. And at the end, of course, I've been engaged in a lot of incidents. I've got a company, Secure. This is the company that I have established 17 years ago. And right now, having a team of more than 60 people, we try to conquer the world with performing the legal hacking activities all around. And we are placed in 4 locations, so US, Dubai, Switzerland as well, and in Poland. As you probably can recognize by my encrypted last name, I am actually from Poland, so there we go. So, long story short, I think I have to mention that Microsoft Regional Director thing, because it always sounds interesting, and people are like, oh, are you from Microsoft? Because it's the Regional Director. Well, I'm not from Microsoft, just for the reference. So why am I Microsoft Regional Director then? Like, what makes it? Well, Microsoft gave me this title, so I took it. And there you go. But this is basically the external role. It's like an MVP, but in business. So that's basically for being innovative in technologies, but let's make it super, super straight. I do not work at Microsoft. And today we're going to be actually hacking a little bit of Microsoft. So that is my perspective. All right, guys. So first things first, before we move on, this is the QR code where you can download these slides from this keynote. So please make sure that you're going to do it. Relax, enjoy, and this is where you find them, and that's it. Yeah? So nothing needed. You just get over there and download, and that's it. Yeah? So there we go. And let's get started. So first things first, I would love to start with a story. And there are so many stories in the incident fields that are super exciting, that are always worth sharing. And I'm always thinking, okay, what kind of story I'm going to tell you today that's going to fit my theme of the presentation? But I think that over here we could start with an interesting story of a developer that was actually supporting one of the companies that's like running a large factory. And what happened over there, starting from the first situation when we heard about the customer reached out and they said like, oh, we've got to run somewhere, this is really bad. They encrypted our systems and we cannot produce because information is actually in these systems and we cannot do anything and so on. So come over and then try to support us. Yeah? So with my team, we were supporting the company. My job is to lead the incidents. I love it. I love when things are on fire. That makes me feel good because like, you know, there's this meme with the dog and the mug, it's all fine, yeah, and then there is a fire. So I find myself to be that dog sometimes, and I like that. And eventually, I'm searching, and I kind of feel I know what I'm doing, looking for things, how hackers get inside, what was the struggle, and all the things. And you know what? The only thing I'm finding is that there is a domain admin that came in, made a mess, and left. So how could it be? Yes, I'm thinking, maybe this is someone internally doing that, like who knows? But then, simultaneously, my team has been doing the research in the internet, within the dark web, finding maybe credentials to them has been sold somewhere and so on, but no, actually this was worse. What happened over there was that third-party developer, he actually published the code that he was writing for them for the public availability on the GitHub with the username and password of the domain admin, mentioning the domain name, which was the company name. So when we found it, my Joe was completely on the floor, and my reaction was something like this. So eventually, I was just curious, like, what this guy would say. I'm like, call the guy, I want to know. And they called the guy, and what did he say? He apologized. I'm like, great, that's very satisfying. Everything is on fire. He says, sorry, that is exactly what we want. So at the end, what is the interesting conclusion out of that is that sometimes, even though we do have a well set up environment, and you would expect that cybersecurity today is on a really high level, then in a lot of companies it is already, but they still get breached because there are these little bits and bytes that would impact cybersecurity process-wise. And you know, when we look into the statistics, we have a 290 days, which is basically how long it takes from the discovery of an attack to the containment, which is actually quite a long time, isn't it? And you know what's the average time that hacker today spends in the network before it's discovered? It's 200 days. And that is the statistic from the IBM and FBI. They've got a very similar one, so you can check. So it's 200 days, hackers in the network. So just imagine you live in a house, and one day you are like, I want to go and pick up something from the basement. You know, I'm from Poland, we pick all things. So when I think about what could I pick from the basement, that would be probably the jar with cucumbers. So let's say that you go to the basement and then you want to pick up the jar of the cucumbers, and then you see this guy sitting over there, and you are like, who are you? And this guy's like, who are you? I've been sitting here for 200 days. That is exactly the feeling that we got when we are basically observing the attacks. And if you ask me about my personal statistics, that is exactly what we see. 200 days, yeah, on average, that is exactly what we see. Sometimes 3 weeks, sometimes a year for a governmental network, ministry of XYZ of a country ABC that I was analyzing. Actually, hackers were sitting there for over 12 months. So if you're wondering whether your data is leaking, yeah. In most of the cases, we see that, and in most of the cases, answer is yes. So, conclusions and concerns. Are we today utilizing our cybersecurity solutions well? Do we do a really good job with those? Yeah, we've got very trendy thing today, which is threat hunting. But not many companies today do the threat huntings with the solutions that they got regularly. How often should we do it? Well, simply, in our opinion, once a month at least. So you should have a procedure where you are utilizing your CM, XDR, whatever, and then you go there and you are like, okay, let me think. Let's find for the attack of that type. Yeah, so the hypothesis-based threat hunting, but how do we do it? We need KQL and stuff like that. We're going to talk about it during this session because there is a certain approach we should take for the upcoming year in order to be responding to the current threats, which I don't personally think with my team that is actually happening process-wise. We can do better, we can utilize things better, and let's talk about, of course, how can we do it. Now let's start with something straightforward. And I would say maybe even a little easy. So let's see. Is being stealth that easy? So let me get into Kali over there. And then what I would like to run, it's the simple attack. Yeah, simple attack because, to be honest, it's an attack that my grandma could run, which is simply the password spray. I wonder if she does this, but anyway, this is the type of an attack that we could run like that. So what we're going to be doing over here, we're going to be checking out how we can see this particular attack in the logs. And I'm going to do the password spray on the particularly domain controller. So let's do the clear log, let's keep it straight, and let's do the password spray for the user Bob. There we go. And then over here, we are checking what we got, and of course, we got what we expect, which is, honestly, as you can see, the full 4625, which is the account failed to log on, network logon type 3. Yeah, so not a rocket science. Okay, cool. So this is the issue that we got, failed logon with the domain account that we got on a domain controller. But you know what's the wrong perception? That all the successful logons for the domain users will be logged in on the domain controller. That's not true. And let's have a look. So what we're going to do right now, we will rerun this particular attack. Let's do it. So 10, 10, 10, 30, and I'm going to run it on a client. But before I do it, clear And there we go. Let's run it, and then let's refresh the situation. And as you can see, the only log that we got is actually related with the log 4776, credential validation. So we don't even see that the failed logon happened. We don't even see that the successful logon happened. It's just the log for the domain user on the domain controller regarding credential validation. So why am I saying this? Because whenever we think about the efficient monitoring in the modern infrastructure, we need to find information sources. And these ones are usually a big deal. Let me give you an example. We were doing this year a really interesting incident. We were doing it, we were supporting it, so that sounds wrong. So there we go. And there was a customer, a big tech company, that actually has been attacked in a following way. So check this out. There is a wife and there is a husband. And the wife, she's a VIP for the project management. She has access to Jira. And she has access to all of the projects, customers' data, usernames, passwords, source code, everything, yeah, pretty much. VIP in Jira as well. Now, there is a husband, and husband works from home. And they figured that she also works from home. So they attacked husband, took over the home computer, where she was storing credentials to the corporate Jira, and then they took the credentials out, accessed Jira, and then downloaded around 21,000 files with all of the data that was for the customers. Just imagine, that's not good, especially in our European conditions where you have to report it into the central, certain identities, governments, customers, and this is an international organization, so lots of entities of theirs were affected, costs, lawyers already engaged, and so on. We are engaged, and there's one big question of the universe. What do we have in this data? So what you're gonna do? And the hackers say, the group is called Hellcat, it's a famous APT group. They say, if you don't pay us within 4 days, we're gonna leak your data. So they're like, okay, so we have to figure out what it is in our data. You're not gonna put humans and then analyze the data, you have to build a quick LLM. So we had to do that. And then we found out, okay, that's what the data is, but first we had to identify what kind of a data was downloaded. So how do we know it's 21,000 files? Well, we could get it from Jira, but the problem was that they were storing the logs locally and they run out of the space. So if you can imagine that there is something ironically that could happen in this situation, it happened. So if you don't have logs for Jira, how do you know what kind of files were downloaded? And the answer is very simple, but they didn't realize proxy logs. So we're like, okay, let's go to proxy, let's correlate. Yeah, so do we have tools for that? Yeah, because it's always a time-consuming process, and I will tell you that every single incident, it's literally the same. They don't know where information is. And it's always very funny when there is an incident, yet another story before I move on to share with you. Big company, like an H&M, not them, clothing company, kind of retail. They have stores all around the world. And you know, they have an incident, typical situation on Friday, 3,000 stores. And I'm joining the call, and I'll just share with you my personal insight that I really love. And I'm joining the call, first one, and there's like 40 guys on the call, and they ask me what to do. You know how fantastic it feels? I'm like, cool. And I'm not showing that to the customer, but I can share that with you. Inside, I'm having this one tear of happiness inside. And I'm like, okay, you tell me what happened. And that's the problem. They don't know what happened. That's why you are here. I'm like, oh, great. So we are starting from the point zero. What kind of information you gather? Yeah, so, I don't want to be rude, but it's always the same thing. And we could do things faster if we would prepare. And that is what we call efficient monitoring. And honestly, after all these stories, there are two questions that must be answered by you. One, what happened? Not like, ransomware happened. No, 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 no. You need to know that there is a process run by that user that tried to connect over there, and there was another entity or identity taken over, and then basically there was another communication, and then this, that. So you need to have that full picture of the attack. Why? Because you need to answer another very important question in the incident, and that is, did it spread? Why do you want to know that? Because you want to evaluate the damage. Like if someone managed to become a local admin on the computer, and then maybe there was a power user logged in this computer, now how? You're going to wonder that, did it spread in a certain way? Like, how are they going to figure it out? You need to have the dots connecting all the time, and for that, we need to have information sources. So when we think about the different ways of hunting, there are certain hunting pointers that are important to put you on a rail where we are analyzing, of course, the password sprays and so on, yeah? And that's why also on a tutorial that I hope some of the guys are here from the tutorial, we were talking about the logon types, and these logon types, they do convert into the hunting practices that we need to always apply when we want to narrow down what we are looking for. And that is basically the logon type 3, which I mentioned, which is actually characteristic for the password spray. So when we are thinking about the efficient monitoring and also identifying the possibly lateral movement, then in general, there's a couple of ways how we are able to perform these steps. And in this presentation, having a lot of information, you can find the different practices of how you should approach certain scenarios. And the lateral movement, which we're going to get to in a moment, has various characteristics. For example, simple scheduled task, attack that I call like from the 90s. Yeah? So how do we find that it started? How do we find that someone created that and there is a process that from the scheduled tasks temporarily deleted itself and then connected somewhere over the network? How do we know that? It's actually pretty simple because this information is out there in Windows. And you know what's the best part about Windows itself? Is that even log, it's very useful, but to be honest, it's a little for kids. Because you can have full monitoring of Windows. That's why, for example, organizations like NATO, military units, and so on, they use Windows because it follows common criteria, which means you can achieve full monitorability of anything that happens. Did you guys know that within the event tracing for Windows platform, you can actually create a keylogger by using the built-in Windows mechanisms? That's pretty cool. So you don't have to run any code. Windows can itself be the keylogger, and then that's it. You can grab someone's passwords without really setting up any of the code. So that is this full traceability that we are talking about. And I'm always saying one thing, to be honest, whoever knows ETW, so event tracing for Windows, gets the growl. Because this is a really, really cool knowledge to have in cybersecurity. But moving forward, whenever we talk about the lateral movement, we also have, for example, classic password spray. So the one that I performed from the very beginning, detection of that is pretty easy. It's nice if you would run some telemetry around it. You can run the telemetry on the host, which is a very simple, super simple script. Or, of course, you can find it better by, for example, playing with the source of lateral movement, and that's basically one of the KQLs. Just have a look. Because in general, that threat hunting or part of threat hunting is something that I'm going to take you to in a moment, and then we're going to be analyzing how we can connect the dots, actually. So priority number 3 is checking for legacy configuration or misconfiguration. And that is after efficient monitoring and also the possibility to identify the lateral movement. So what are we talking about? There's so much. I don't even know where to start with. One part, it's the NTLM. Another part, it's the old configuration of SQLs, which is like happening all the time. You have a clear text network traffic, for example, So let's get into it, and then let's see how we are able to run the scenario first, and then I'm going to show you how we are able to mitigate it. Now, important part is, you want it or not, there's one thing you will need to plan your time for in 2026, 100%. NTLM version 2 phased out. And Microsoft is deprecating NTLM version 2. It's great news, but it's also a lot of work for you. And it's not very difficult. You can just go to the group policy and say disable, but we don't want to do it. So eventually, we first want to prepare well, and I will tell you, of course, in a moment how to do it. But let's first talk about how this could be used in a sneaky scenario, which, to be honest, is one of my favorites. And let's see, of course, how we're able to work on that. So what do we have? Here we've got the net exec. We're going to scan for shares. So once we did the password spray, we already know how to use it. And then we are scanning for shares, and then we can see that Bob has access maybe to some of the shares. And we can see that, on the server number 1, Bob has a read and write access to documents. Like, for sure, there is some share in your environment that users has access to. Okay, so the next part is going to be, we're going to look into that share, and let's see what we got. Yeah, we are Bob already, so we can do whatever we want. Now, there is some stuff. We've got some files generated, yeah, so it doesn't really matter. But the good and interesting part about that is that we can create over there a shortcut. And that particular shortcut, let's get into it. First, let's put the script. So we will do it like this. The script basically will be, and let's do the PowerShell, will be actually related with one interesting thing that is working in Explorer in Windows, which is basically the case that you will be able to query the network where the shortcut is out there. Anyway, let me show you and explain. So when we put the code over there, let's put the secure over here. So we got a C secure malicious. We're going to create a malicious shortcut link. And then 10.10.10.106, we're going to be connecting to Kali. Yeah, and then we can, of course, verify whether that works, and that's working. So this is a very simple content of the malicious LNK that we're going to be leveraging. Yeah? So let's have a look. So here, we've got this malicious. Yeah, so there you go. And that malicious is something that we're going to copy into the share. Now, the problem today, today and forever, since forever, is that when we look at that particular shortcut, and when you just put it on over there, and when someone just opens that folder, let's do sudo, and then responder, -i eth0 to listen. Yep, let's put the password. And then when someone opens up that kind of a share, there we go, you have an SMB monitoring. Then we're going to be capturing authentication of that particular user. Yeah, so that's actually pretty awesome. So when we go to the documents, that's it. Yeah, as you can see, we've got this malicious stuff over there. Then, of course, let's have a look what we got over there. We managed to capture that Bob's hash already. Isn't it cool? So you know what? Sometimes I feel there are certain areas where in technology we are progressing like crazy, but sometimes we are not. And you know, Stuxnet back in 2010/2012 was actually leveraging a similar thing. So you had a shortcut, though there was a problem of how things were loaded through the shortcut to the memory, but also it's enough to display the shortcut so that things from the shortcut are loaded to the memory. That's why we have a shortcuts for, to be quickly executed. Why we don't even launch them, but when we look at them. So let's have a look what we got, and that's uber cool. So we've got this. So our job is going to be to capture some juicy guy. And Bob is Bob, yeah? So we might be actually waiting for some privileged user. And that's going to be pretty awesome, because yet again, we will need to create a scenario where we're going to be capturing simply a user like that. So when we're going to hit the documents, yeah, then we've got this malicious one. And depending on who enters, just enters that share, have a look. We've got here an admin. So there we go. And then what we can do, well, in another very romantic way, we can take that and then try to crack it. Yeah, so we got a nano, yeah, and then we can put it on. There you go, and we're going to be playing with that, and that's not that much of any of a challenge, yeah? So we've got a John, yeah, format, and then we will specify that that's the net NTLM version 2, wordless, passwords. Of course, the wordless is short, because it's a session, so it has to be quick. The password of an admin is password, lovely. Yeah, so that's not very challenging. If you got a good dictionary, then this is awesome too. And then eventually we'll be able to push it forward. Yeah? So we can do the netexec, and then we can specify over there that we're going to be doing that gen relay list, and then from the targets, yes, so we can actually use technically our credentials for this in order to specify the targets that we would like to get access to, so we can automate it a little bit. And then we're going to do cut targets so that you see, yeah, we've got a 10, 10, 10, 20, and then 103 and 30, so that's our server client and another member server. Yeah, and then we can do the in-packet NTLM relay X, and then we specify the targets, and then we've got a SMB2 support, and then we do SOCs. So we're going to be hunting for the connections on SOCs. So let's wait, of course, for that. So let's set it up. That's it. And right now, this is beautiful because any connection that we're going to capture like that on that particular share, yeah, we're going to be technically getting, and then we'll be able to process it forward, yeah? As you see, it's pretty noisy. So the next part, yeah, you can see that the admin succeeded. We managed to get access as an admin. Yeah, we've got the session. Yeah, so that's not very difficult, as you see. NTLM relay X. And then we've got the session already opened. So obviously, yeah, let's have a look. We've got the proxy chains, and we've got the configuration. Let's put that on, and let's verify whether we will be able actually to pick these connections. And this is pretty easy. Let's just go. Yeah, so we've got here SOCs for 127, and then we just need to change the port to 1080. And then the next part is pretty straightforward. Yep, here we're going to be just accepting connections on the port 1080. So we just wait for that. And then let's run the proxy chains, netexec, and then we've got a SMB 10.10.10.30, and then minus user admin. Then we can put in any password, doesn't matter, because we're going to be rerouting the connections right now to ourselves. Yeah, and as you see, we've got that working. Okay, good. So we will actually make sure that we're going to get, of course, the answer and execution LSA of all the hashes that are from these machines. We can do the same story by using SAM database, yeah? And at the end, there you go. Yeah, you've got the hashes. So, I mean, it's kind of easy, isn't it, yeah? Thank you, guys. Am I speaking too fast or something? No, okay, good. I got overexcited, I will tell you. So, yeah, so thank you. So, yeah, you can see that at the end, lots of things can happen by using NTLM version 2. And we could be like, yeah, there's a relay and that's it. But don't forget about one thing, that when we're going to be looking technically into the ways of how we're able to disable NTLM, then it's not really just a matter of that. You need to make some tests. So you need to see which applications are actually leveraging NTLM version 2, because if you will just do that, we can break things, yeah? And obviously, I don't have to say that, you know that. But sometimes we're like, okay, so I have to plan this, I have to do some more operations around that, and don't worry, because we got you covered. Scan that QR code, it's going to take you directly to the PDF. This is the PDF that we wrote for everybody, including our customers, and this is the way how you phase out NTLM version 2 in a nice way. So you have a pre-stage implementation phase, testing phase, logging phase, name it, yeah? So basically, fire up this document and plan your operations so that next year, I hope when we're going to see each other here, there will be, everybody will say, like, we all deprecate it, we all phase out NTLM version 2. There we go, yeah? So fingers crossed for that. So this is how we can do it. And lots of the attacks are possible because of the NTLM version 2. But I have to say that when you're going to, for example, do that password spray, by default password spray it runs on the NTLM version 2. But if you use -K, it runs on Kerberos. So we are not preventing password spray. We are, though, preventing the possibility to relay the identity to our target machine. And that is really what we will need to fix. So this will probably fix, in my opinion, like 80–85% of the attacks which are running today. Now, some time ago, I said the pen testing is boring. I mean, honestly, every single time you connect to the network at the customer side, how exciting it could be that you get access every single time. Like, how many successes in a week you could have. So this is the moment where it becomes boring, and that is all because of the NTLM version 2. And I'll tell you, actually, fun part. I was doing the pen test in Bahamas. And I'm not showing off. This is basically, it sounds cool though, but it's getting dark very early over there. So when you go to the customer at 7 a.m., it's dark. When you leave the customer at 7 p.m., it's dark. You depart on Friday, it's dark. Yeah, so basically that's the Bahamas project. Yeah, it sounds exciting, but it's not. Anyway, on Monday, I am starting the pen test, so I'm excited. I know how it's going to end, but let's give it a chance for the 1,000th time. And then basically, I'm sitting in a room and I'm doing the pen test, and I'm not seeing anything. I can't do the relay. I'm like, what's going on? I'm probably silly. And you know, you've got this, in IT, we've got this imposter syndrome a little bit, so I'm thinking, it's probably me being silly. I'm so silly. I'm so not smart. And I'm restarting things, and I'm getting desperate. And I'm like, no, it's probably not me. And I'm getting out to the IT. I'm like, where is everybody? And why NTLM version 2 wasn't working for a couple of hours? Because they were all sitting in the room eating donuts and doing nothing and talking about how was their weekend. So this is the longest time it took me to hack some company, but normally it's like 5 to 10 minutes because of the NTLM. So there you go. We have to get rid of that, and let's make it clear. Good. Absence of insights. Looking for persistence. I love cat and mouse game. It's awesome. Yeah. So they try to hide, and then you were like, yeah, I know how to find you. So it's awesome. Yeah. This is very cool. It always feels like a puzzle. But what you need to do is to make sure that you have your own checklist for looking for persistence. Persistence is hiding, or the possibility of hiding by malware / by hacker in your environment. And we look at the persistence from two different angles. One type of an angle is persistence through misconfiguration, and another one is persistence that's used by malware. And yet again, the list is long. Sometimes it might be added permissions to the admin SD holder. Sometimes it might be basically some persistence that's added through the different Windows auto-running mechanisms. Yes, sometimes it might be permissions on the object. Sometimes it might be the hidden permissions that are on the object, so the G permissions. So there's so many ways of how you're able to be sneaky. But if we know how someone is sneaky, then we can hide. Now, probably the most sneaky thing that I've seen from the persistence perspective being built in the attack, and I want to share that with you before we move on, was actually the attack that was happening at the customer side. And what happened there, it was that they called me, and then I'm joining, and then it's a situation where nobody can log in anywhere. Nobody can log in. Why? We don't know. Yeah, so where can we log in? We can only log in on a domain controller. And when I'm logging on a domain controller, what do I see? And this attack was happening in May this year. And what do I see is that domain controller has the date July. Interesting. So what they experience, spoiling and shortening the story, they have experienced the denial of service on the NTP. NTP, it's a clear text. What's your approach to NTP? In most of the cases, people are like, we use it. Yeah, but is it actually secure? Because in vast majority of cases, it's a clear text. So what is though interesting is that NTP thing, caused, of course, everybody to not be able to authenticate. That's fine, we understood that. But you know what was the problem? Is that we were looking later for logs, because this attack was lasting around 20 minutes. And after that, we all were back to May. So question is, how will your solution process the dates from the future? Did you guys check that? I mean, why would we actually check for that particular thing? But think about it, because they were using actually a pretty known antivirus solution that's there, no names, but there you go. And that particular antivirus solution was actually, EDR that they were using, was actually allowing you to only go in a website that you could go to 2 days from the current date to the future. So I was like, okay, let's have a look, let's see. Nope, only 2 days, because there was a limitation in the software. Funny. So we lost big portion of data that was actually related with an attack. I found it geniusly evil. Yeah, if I'll be evil, I'll be doing that because nobody could find what was going on. Of course, the only one that could tell us the truth was the USN Journal, because USN Journal always picks it. And then another perspective is going to be, what is your strategy on the USN Journal? And the reason why I'm saying this is because persistence very often can be traced by the best golden log that's out there, which is the USN Journal. And USN Journal should be set up to be around 1 gigabyte. You know why? Because when we look into the statistic of 200 days, that 1 gigabyte could be actually enough to hold that amount of data. And that is precious, and every single incident is containing the research around the USN Journal. But before we get there, a couple of comments for the persistence. What I would love to show you, it's an interesting perspective on persistence, which is actually, let's have a look, related with injections into LSAS. And injections into LSAS, let's do who am I, administrator, will allow you to get credentials. And let's have a look how. We got a host name, Windows 10, okay? It's going to also work on Windows 11, by the way, but I got this machine here. So let's go into the tools, and then we're going to use for this purpose Mimigat, x64. Why? Because we're going to just register over there the simple memSSP. And memSSP is the one from the supportive authentication. Privilege debug, because we have to be able to open the process. Then let's elevate the token in place, so we get a token elevate. There we go. And the last part, and this attack is also very, very easy, you can actually use over there the miscellaneous, and then you could do the memSSP, and then we got this injected, and we've got the extender, so the service provider for authentication actually added. So when we're going to do the connection right now to the domain controller, and if you got credential guard, it will not save you because it's a different place where we're injecting things to. So we're going to put in the data of an admin. There you go. And then we're going to log in. Okay, so let's get into the DC underneath. So let's see whether we are in the DC so that you guys can see. And who am I? We got that admin, lovely, host name, and then that's a domain controller. Perfect. So the question of the universe, and let's switch here back, okay, cool, is what kind of a data did we manage to capture while we were performing such operation? And here, we're gonna get into the Windows and then System32 because the memSSP actually creates the log. So if you're gonna use it, yeah, the log is basically there. It's going to be updated with the password that we typed in for an admin. So we can have a look what we got. We got a Mimi LSA, and then we got the log that is there, and then you are able to capture the admin and the password. So anything that the user types in the moment of authentication, you're going to get. Now that is only possible if you can open LSAS for the injection. And if you have any kind of LSAS isolation implemented, then this is the only condition under which you can do it. So, question is, can we open LSAS in your environment? And think about it, because LSA isolation, to me, it's one of the most important things that would prevent a lot of attacks. And very often, we can do it. So, we got that. Now, one type of a persistence is this. Now, another type of persistence that I'm thinking about is actually related with the knowing in general your passwords or profiling the machine. And I mentioned that briefly on a tutorial yesterday, but let me say it from a different angle. So first, maybe a little bit of a story. There was an admin, cool guy, nice guy, but a little messy. And what he did, he was just supporting people in some forums. So he came to the forum and he was like, oh, you got a malware, not great, let me support you. So, good. So he was a nice guy. I mean, yeah, I met him, as I mentioned, cool. So there's a problem because someone replied to his message and said like, oh, dude, good that you are doing that. I got a cool software for you. Have a look. Your malware analysis is going to be nice and shining and quick. So he clicked on that, which I was analyzing his workstation, and he downloaded the malware, which was called file 37.7zip, and 2 seconds later, he fired it up, nothing happened, that's it. 3 weeks later, everything stops working, and their cloud is taken over. And we were analyzing, and together with Microsoft, first we were recovering their cloud, but then second, we were analyzing what actually happened in that cloud, like why someone managed to get access to his global admin account, which obviously he was storing credentials in a browser, and then managed to get access to the cloud. And you know why? That it was possible? We could be like, where is MFA? So when we were analyzing the configuration over there, his account was the only one that was exempted from the MFA. And I'm like, dude, why? And he's like, because MFA is for users. I'm like, wow, that's really heavy. And you know what? This guy, he's no longer working there, by the way. So this guy was actually storing 127 credentials in the browser for the administration of their environment. Cool dude, nice, but not really following procedures and not really knowing the cybersecurity hygiene. So when I learned that, I was like, what, 127? My reaction was something like this, yeah? So the question is, when the attack is happening, what do? How do we scope our workstation that has been attacked? Because we could be like, oh, we're a corporation, we don't care, we wipe it, we got a new one, there you go. But what if user actually stored some credentials that were important, maybe to Jira, who knows, in the browser or somewhere? Like, how do we profile it? And to be honest, there is a very nice way of doing it, and that's maybe a little heavy, but every single, to be like 99%, yeah, 95 to 99% of the different credentials and the cryptographic blobs that people store and applications store, they are actually stored through the data protection API in Windows. That's my completely favorite subject. And again, I'm not showing off, but as far as we know, we are the only team and the first team in the world that fully reverse engineered data protection API. We decrypt everything that moves, and I will tell you everything about it if you want to know. But when there is some kind of a credential stored somewhere, I would rather know, because maybe this is the access to Bloomberg, Reuters, name it, some business applications. So for this, we've got a tool that you guys really want to use, because there is no other tool like that, as far as I know. Maybe there is, but as far as I know, there isn't. So if the user stores password in the browser, and there is actually the password stored in a Google Chrome, yeah, Chrome Pass is opening it because I'm running this as Freddy, so I'm that user. But you may not be this user when you're going to be analyzing the workstation. You might actually have a disk offline, and then you're asking the question, to what kind of components user actually stored the password? And here comes the answer. There is a tool, which is honestly my favorite tool, CQDP API blob searcher. And then you specify the blob, so the disk that you would like to search, so let's say C drive, yeah, and you can keep it like that. And it's going to scan your whole C drive for all the ways of storing credentials. And as I mentioned, in Windows, it's the same way in 95 to 99 cases. Yeah, so it's very comforting. Plus, if you are in Germany, then it's ethical too, because you're not going to be revealing users' passwords, which privacy laws maybe sometimes we're not allowed to, I don't know. So yeah, anyway, we do it ethically. So we've got this, and we do the updata. I'm going to go to the Google Chrome to speed it up, and then we do the recursive search, output to the CQ tools, and then let's stream it to the dpapi.txt. Yeah, around 10 seconds of a research, dpapi, and bring it on. We are learning that there is actually the password stored in cookies. We don't see the password though, but we see the way how it has been secured. So you are like, okay, so let's have a look into Google Chrome, because you don't know what you don't know about. You don't know what kind of places or apps or in general credentials user might be storing. Some data in Google Chrome, in the login data, there you go. So this technically sets up your scope, and then you can decide which direction you want to go. Yeah, so I'm using this every single time. In the incident, it's awesome. And then we're like, okay, so we have credentials stored here and there. So general threat hunting skills, beautiful. So there is a bit of a problem always. And I'm always putting this in the either resources, procedures, tools, skills. Yeah, so all of that bring the issue why we're not doing the threat hunting. We've got the tools, in most of the cases we do. We've got skills, not a problem, we can learn. Do we have a procedure for that? We can always create it, yeah? What kind of data sources we collect the information from? We can always analyze it, but that must be done, and we call it an incident response readiness. And that readiness, it's a bit of a trend, to be honest, when we are looking into the ways of how we are able to hunt for the incidents. And of course, AI can support us, and then we are able to create a really nice approach to that subject by, for example, looking into our threat hunters guide. Scan the QR code and enjoy. So that next year we see each other, there will be no like, oh, we don't do threat hunting thing. Because this, and I shared it with the tutorial guys because it's in general our community little initiative, 113 pages. Like, come on, weekend is coming. You at least have to do something. So why not doing that? So have a look at the document, and these are all KQLs defining you the search scope or the hunting scope from that angle. All right, so have a look and enjoy. MC bypass attempts. Good, how do we hunt for that? Or time stomping for the file stamp modification, which is also typical where the malware is using. You can put it out, by the way, also from the USN journal. As a basically basic data change. Lateral movement, there we go. Remote service creation via WMI. PSExec, like network connections. Yeah, just check it out, because these are the things that I would check for, my team's gonna check for, you're gonna check for when you've got a well-designed threat hunting. Okay, so enjoy. Good, so let's push it. Long story short, whenever we look into the hunting, it would be lovely to have a look at the one scenario, if you don't mind. And within this scenario, I would love to also show you the interesting way of how we are able to look into the threat. So let's have a look. So long story short, there's going to be, as always, starting with the Kali, we do the bloodhound, we set it up. Yeah, so we're going to be scanning and creating the domain snapshot by using the user Stephanie Barnes with the password coming from the password spray maybe. Yeah? And we've got these files created. Lovely. So this is a typical activity over there. So we're going to be running Bloodhound over here for scanning of the network environment, of the domain environment. So let's put it on. And right now, what we're going to do, we will, at that certain stage, put here the files that we managed to collect. Yeah. So these are the ones. Yeah. So we can take them and we can put them on the hunt, and then we will be able to analyze them. This is actually pretty cool. And let's upload them, and it always takes a little bit of time while, of course, that analysis is happening. So while we go into the administration over here, we will be seeing this ingesting status. This might take time depending on the size of the domain. Mine is small, so we've got the complete status. All right, so we're going to go to the Explorer, and this is the moment where we can search for Stephanie Barnes, since this is the user that we have based on the password spray. Now, we can analyze, of course, what we see, and it's always good to see the outbound object control. And the outbound object control is to the Sam Smith. We've got here the generic right and the force change password. Now, interesting discoveries we can make. Sometimes we might be thinking, okay, why is this even the case? Why is this even the case? But you know what? I've been doing the pen test in one of the banks on one of the countries in Far East. Just imagine what I discovered with the Bloodhound was actually the 420-something, I don't remember exactly, workstations that had a write access into one of the group policy objects, which means every bank employee that had that computer could become a domain admin just like that. And when I told them that, they were like, oh, we didn't know. How come? Who did that? Someone must have done that, but they don't know. So these kind of flowers, as I would call them, or raisins, or cherries, or jewels, are always to be found in the network. So there we go. Cool. So we got that. Now we can, of course, have a look. So we can confirm that. So we get a net RPC password, And then we're going to be setting that for the, let's just do the password 2, setting that for the SumSmith. Because if we can control that object, we've got a possibility of doing that, right? So let's give it a try. And we got this. OK, awesome. And for the check, we can be also running the netexec. Maybe we can run that to check whether this actually worked. Yeah. So we got over there the SumSmith password 2, and we got that. OK. Perfect, works. So it means we have a control. Yeah, so what was written there in the Bloodhound actually is like it is. Now, we are SumSmith. Good. What SumSmith can do? Outbound object control. Yeah, we can see that. OK, SumSmith basically has an access to these computers. OK, so we will be able actually to also analyze it. Now, depending on the settings, sometimes escalating it a little bit, we might find here we don't have really outbound object or execution privileges and the object control, but sometimes we might have, depending on the apps that we were using before and so on, different settings, including, let's see, the unconstrained delegation. So we've got the allows unconstrained delegation true. We've got over there the generic right. And that is a deadly situation, because you are able to make this guy to be anybody this guy wants to. And that is ultimately we want to in life and in the Bloodhound. So there we go. Let's see what we got. And eventually, we're going to get into the setup where we're going to be testing what kind of access this guy possibly could have. So we've got the netexec, LDAP, and then over there, password 2. We're going to be looking for how many times we can add the computer into the domain. And known to us, old setting, machine account quota 10. I'm using it very often. So we're going to unpack it, and then we're going to be adding a computer. So we're going to create the computer account because we can. And then we're going to call it a CQ comp. And we're going to be doing this as SumSmith because we can. So every user can create up to, by default, 10 computers in a domain, unless, of course, you change it. Yeah, so this is the health check. Lovely. Let's authenticate. We got that one. OK, lovely. And then we got to successfully add it with the password 123, which, yeah, there we go. RBCD, Python, and then we're going to be with that testing what kind of options we got. So we got a DCIP action right, and then we will specify over the delegate, and then we will see how we are delegating. So we are delegating to the Windows 11, yeah, that we got, and delegate from our guy, because we will be technically using that guy to impersonate into whoever we want to, and that's like interlayer that we're going to be using. So we get a secure, and then we get a SumSmith, and then we're going to put the new password too. There you go, and yep, good, we got this. Perfect. So have a look what we got. Accounts allowed to act on behalf of other identity, CQ host. Delegation rights modified successfully. Perfect. CQ comp can now impersonate. Let's rock it. So with the next stage over there, it's going to be related with technically specifying that we would like to impersonate an admin. Yeah, there we go. And we got this. So saving ticket in admin. So we've got the ticket over there. Great. So the next part is how do we actually leverage this ticket? So we're going to be actually using it right now. So we're going to export the ticket, and we got that. And we're going to be using the netexec, which is super functional today, to authenticate by using the use cache. And then let's see whether we're going to be actually logged in as an admin. And as you see, we are. Now, you can imagine all the other things that are not interesting, like, you know, the DC things, starting remote desktop connection with the hash, like all these things is like we know. Yeah? So with that simple steps, we were able to eventually, by leveraging the unconstrained delegation, to take over the whole domain. And it all started with just one user that had a write access where it's not supposed to have access to. So how is your status? How often do the Active Directory health check? And to be honest, I think, and my team thinks, that while threat hunting should be done once a month, Active Directory health check may be a little bit longer, but so use it every 2 months, every 3 months, yeah, depending on the size, but check, because the infrastructure is alive, and basically we need to make sure that all is good. Now, The priority number 6, we're almost done. Incident response readiness. Well, you know that already. So we need to make sure that we are connecting the dots correctly. We need to make sure that when we collect the dots, we know how to find the indicators of the compromise. We know how to collect the data from the machines. And we know what's the status of our vulnerabilities in the infrastructure, because they all create our response to the incident, and they all formulate the hypothesis that we are able to set up faster so that you can hunt for the problem faster. And when we think about the different ways of how you can actually approach this, there is one suggestion, and I'm always really loving those guys. In Australia, in the government of Australia, they did this quick, nice-looking cyber incident response plan. Have a look. It's not perfect, but it's a really nice, motivating document that you might find actually inspiring. So there we go. And when we think about the ways of how we collect the data, well, first of all, this is the baseline. This is the list of things that you must know how to collect quickly. Yeah, this is what we always collect very, very quickly. Now, if you are like, I want to know more, you are switching to this list, and then basically you are collecting it a little bit slowly, but this will be more informative or supporting your actions while there is, of course, an incident. But before we move on and finish up, what I would love to share with you, it's a quick scenario that actually we've been in while we were in the incident. And let's have a look at that quick demo. And that quick demo is actually pretty quick. But the situation is as follows. There is a hospital in one of the European countries. And there is an incident. And I'm there. And you know, like people die there, so you don't want to be slow. You would rather be fast, because you don't want to be responsible, or at least not even know about it, for someone's unfortunate situation. So what is the thing? The thing is that they got basically ransomware. They got encrypted, and we're trying to recover things, and so on. And there is one database server that I'm trying to get access to, and I can't at the very beginning. So I'm asking the local guys, like, where's the SQL guy? Give me the SQL guy. And the SQL guy is on vacations. So you can imagine, like, you know, hospital is on fire, people are like, they cannot get access to the database, and this guy is like this, you know, this music from the tropics, tum, 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 and he's like drinking like some drink, and then there's this fire, and the path over there is very, very short. So we are like, okay, let's call the guy, because he for sure knows some passwords and stuff like that. He's the only guy that knows it. That's already wrong. And then he doesn't pick up. So what do we do? And there we go. So let's have a look what we got. So we're gonna get into that little SQL. Yeah, and we've got an admin account. And we try to get access to the SQL server. Eventually, yeah, we'll try to do that. So we are logged in, of course, as an admin. Yeah, we go to the tools, and then we go into the SQL Management Studio, and I'm gonna run it with the administrative privileges, because when you run it like that, that really makes a difference. But still, even though I'll try to run it, let's give it a try, how it would work. I think I will not be able to get access to it. So yeah, the Management Studio always starts a little bit longer. So I'm going to go to the services.msc in the meantime, and then basically play with that. Okay, cool. So that is there. And I'm like, okay, let's get access to the SQL. There you go. Yeah, let's connect. And then this one says like, yeah. So that's the moment where we call the guy. The guy doesn't pick up, so what do? We actually go to the services, and then we find the service, this is this one, and then we go into the properties, lovely, we stop the service, okay, and then my favorite, basically you take that path, and you know, without really thinking too much, you can switch off your brain and you can be like, la, 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 because this actually is gonna be cool. You can start the command prompt, run as administrator, there we go, we paste that path, we do the -m, and then we run it, we wait, good, and we run it within the recovery maintenance mode, and then as an admin, we just do like root, connect, and then basically it works, yeah? So that is basically how we do it, yeah? So what I'm trying to say is that we need to know these ways. Yeah, so what's your backup plan for the resources that you got? Because when things are on fire, it's not great. Now, cool part is that I have here administrator, which is the different account, and I don't even have my admin over there, but I'm a sysadmin already, yeah, so I can add myself, and there you go. If nobody invites me to the party, I'm going to invite myself. I'm from Poland, and I'm always saying, access is denied, it's an invitation. It's always a good approach. Yeah, so there we go. So, at the end of ends, when things get dramatic, what happens if the hacker takes over an ID? And that's my favorite checklist. And I got a homework for you, I'm sorry. So please take that checklist and write an appropriate action plan, because if the domain is attacked, you have to do this. Yeah, so like things like resetting user passwords, like this is boring, but then resetting computer, service accounts passwords, Kirby, TGT, immediately, twice, which normally you're not supposed to do it, but in that case you have to do it. But then when you think about it, that's more. You have to reset labs password, you need to look into the admin as the holder, look into the malicious scheduled tasks, look into the security descriptors. Yeah, you also have to check out and revoke certificates, verify the certification authorities, and in general certification services escalation points, which is very popular right now, but there you go. We've got more like this. You look into the cloud, there you go, and then you look into the group policy a little bit, here and there, enter ID, and then maybe you also look there. You should see your face expressions right now. You're like, oh no, yeah, there you go. But honestly, write a technical response for each of these steps, please, so that when things happen, that is exactly what you will need to do. And when there is this call and the guys ask like, what do we do? Tell us what to do. I'm pulling out the checklist and I'm going through the checklist, because there needs to be a checklist. Yeah, we need to be that dog with the Mac. It's fine, yeah? And then you execute the checklist and then you are good. Okay, we're not done. This is step number 6, yeah? So depending on the situation, of course, and whether you got PAM or maybe ADFS or whatever, you have to check, yeah? So it's not that bad as it looks. So basically, just take the checklist. It's in that QR code that I've been presenting for the presentation. And if you didn't scan it yet, do it, because the checklist is there. And of course, I hope that you're going to enjoy it and you're going to be ready when bad things happen. So, summarizing. We were talking about the efficient monitoring, yeah? We need to be knowing our information sources. We need to be analyzing and knowing sources to be able to connect the dots, to say what happened, and the point number 2, did it spread? Now, legacy solutions, they become legacy. Things are becoming misconfigured. Certification enrollment website, why do we even still have it, yeah? So these are simple things, but sometimes you might have the communication in between the SQL and the app being not encrypted, and that could be a source of a problem, yeah? Looking for persistence, have your checklist. Also, don't forget that the general hunting skills are as good as your skills, resources, sources of information, the tools, people, but that is all basically to be put into one process and done once a month. Design your backup resources for the resources that you got, like, for example, the SQL server that I was mentioning. And at the end, of course, don't forget that cybersecurity, it's not a quick design, it's an ongoing process that requires continuous looks, and that becomes one of the most important subjects that impacts our company's resilience, as we all know. And at the end of ends, I started to play the outer game, and we wrote our magazine. This is the first edition. Have a look. It's free. And it's going to be the official magazine that we're going to be issuing every quarter. So enjoy that. Yeah, what can I say, guys? If you will have any questions, I'll be right there. And thank you so much for being here. It's always a pleasure to be part of ESPC. So it's an honor to do the final keynote. Thank you so, so much. Thank you.